Here's one more analysis of variance problem, and it's problem 30 on page 514. So let's read the problem here. It says, go to the Springer website, and he gives a website, to find files related to this book. The data file Singers contains data on heights of sopranos, altos, tenors, and basses in the New York Choral Society. Okay, so last time I checked, it's been a couple years, last time I checked that link is dead. But years ago I did get this data, and I still have it, and I'm going to put it on the website or email it to you. And so it's just another analysis of variance problem before we get to the match pair analysis. And I always like this problem. The results are kind of obvious. What's going to happen are the differences between altos, sopranos, altos, tenors, and basses, and singers in heights. Well, of course, because two of those groups are women, two of those groups are men. And so you would expect some significant differences. And so they're, of course, they're measuring it through the New York Choral Society. So I'll have this available. And you can see all the calculations involved in doing analysis of variance using on a spreadsheet. So this is the fastest way I can figure out how to do it on a spreadsheet. Using the sum of squares analysis, and it's a mess. It's a mess. But if you got it, if you look down the very first page, the heights of sopranos range from 60 inches, which is 5 feet tall, up to 68, which is 5'8", which is my height. So the tallest soprano is as tall as me, and I'm not very tall. So the altos range from 60 inches to 72 inches. So they have a 6-footer in their group. Tenors range from 64 inches to 76 inches, and basses from 66 up to 75 inches. So tallest person is a tenor who's 6'4", and well, so the it didn't look like I calculated the means of these. So I thought I had, but I don't have the mean of each group. No, I take that back. The means are on this first page here. The means of the sopranos is 64 and 0.25, 64 and 1/4 inches. And so that'd be 5'4" and 1/4 inches. Altos, their average is 64.89. That's like 64 and 5'4" and 8/9 inches. Almost 5'5". So they're about the same as the sopranos. The tenors average out at 69 inches, about 5'9", and the basses are a little taller, about 5'10", almost 5'11". So anyway, there you go. And the mean of all these people is 67.12 inches. So that's about 5'7" and 1/8 inches. All right. On the second page, I've gone through and calculated. It's been years since I've done this, so it looks like I did residuals in the first set of calculation, and then so that got me the residual sum of squares. I got the independent variable sum of squares in the middle part of the page. Did those calculations and had the sum of squares at the bottom, and then there's the total sum of squares. We get to the last page, and there's the analysis of variance table, and so it all the calculations are there. And let's just talk to it briefly. That, you know, I got the sum of squares for the independent variable versus residuals versus total. The proportions, ISS is 0.57, so that means that R squared is 57% for this problem. So 0.57 or 57%. Now the degrees of freedom, and I want to go over that one more time because this sometimes is a little bit confusing on these analysis of variance problems. There were 4 groups of singers, you know, soprano, alto, tenor, bass, and or 4 categories. And so the degrees of freedom will be 1 less, 3. So that's why the numerator degree of freedom is 3. And then the sample size was 130 people. And 130 people, subtract 1 from that, n minus 1 is the total degrees of freedom, 129. So you'll find total degrees of freedom, 129, the Independent variable sum of degrees of freedom. Numerator degrees of freedom is 3. Subtract those, you get the residual or denominator degrees of freedom, 126. So that's where that comes from. The mean square, again, you take the sum of squares and divide by the degrees of freedom. So the first mean square is, you get it by taking 1058 and dividing it by 3, and you get roughly 352.84. And then the next line is the mean square for the residual variable, and you get that by taking the 796 number divided by 126, and it was only 6.32. So when you look at that, you say, well, there's this huge discrepancy between mean squares. The numerator mean squares is far larger than the denominator. That means the F ratio is very large, and it is. The F ratio is, again, calculated by taking the top mean square divided by the bottom mean square. So you take 352.84 divided by 6.32, you'll get 55.80. That's a very large F ratio number, and the p-value is would be extremely small. It would be less than, we would say that the p-value is less than 0.001. If you want to throw another 0 in there, 0.001, that'd be okay. But actually, it's very, very small, and I used Excel to calculate the p-value, and it's probably goes out about 8 or 9 digits before you start seeing things that aren't zeros. So it, for all practical purposes, the p-value is so extremely small. That means what? That means that there are significant differences in heights in these singers. Surprise! Yes, men are taller than women, so you would expect this result. And so I just talked through one more of these, and if you want to see how those calculations are done, again, I don't expect you to do all the number crunching involved with sum of squares. It's just not worth it in this class. There could be some of you who may end up doing this someday. If you, for example, if you're a nurse pursuing a master's degree in nursing, you may have to do a thesis, you may have to do a study and take statistics. You may have to crunch some numbers. And usually graduate schools in nursing have their own particular statistics course just for that. And they'll give you software, show you how to use it, and so you don't have to do all the stuff I did on mine. But anyway, so we verified kind of the obvious here. And my only other comment, the New York Choral Society, I think might be the only one that's older than the, I don't think it is as old as the May Festival in Cincinnati. So since we're Ohio people, the Cincinnati May Festival chorus may be older than the New York Choral Society. I think it's actually the oldest in North America. So not quite as large, I don't think, but they have over 100 people. So just a little bit of trivia there. All right, let's go on to match pair analysis. Well, oops, I forgot a little something on this problem. So before we leave it, let's look at R again, and R squared. So because the p-value was so small, we know there's a significant, statistically significant differences between the four groups of singers. And but we got R squared. The proportion was 0.57, so that meant that 57% of this data is explained by the relationship between the voice, soprano, alto, tenor, bass, and the heights. And then what is R? How strong is that relationship? So I'm going to take the square root of R squared, and we get 0.75. So R equals 0.75. So that tells us that it's a strong relationship. So strong relationship between category and height of singers. So anyway, I thought I'd better throw that little bit extra in because that's also part of the analysis.